Hi, and welcome to Section 2. In this section, we will be going over UV mapping and texturing an object within Blender. In the last section, we went over the basic features of cycles and organic modeling using curves. Throughout this section, we are going to learn about what UV mapping is and how 3D objects are converted into a 2D representation. We will then apply this theoretical knowledge into practical use within Blender, and tweak the UVs to suit the textures we are using. Lastly, we will go over the different image texture types and how they can affect the visual fidelity of a mesh. In this video, we will be going over an introduction to UV mapping in Blender. We will learn about what UV mapping is, what seams are, and finally the different UV unwrapping modes within Blender. The first question undoubtedly is, what does UV mapping mean? Essentially, UV mapping is the process of taking a 3D mesh and unfolding it into a 2D representation. To convert a 3D mesh, Blender must split some of the edges apart to allow for the unfolding of faces. In the image shown, we can see that Blender has cut along the dotted red lines. These are called seams and can be modified to tell Blender where the mesh should be split. Once the faces of our mesh have been unwrapped, they can then be projected onto a 2D image, which is then mapped back onto the 3D object. Using textures like this can make 3D objects seem much more believable and real, compared to just using shaders and materials. To accurately unwrap a mesh, it is often a good idea to use seams. Within Blender, edges can be marked as a seam with a red line. They will then be used to determine which edges are split in the UV map when the object is unwrapped. When unwrapping a mesh in Blender, there are many different options. The main options we will go over include default unwrapping, smart UV projection, following active quads, sphere projection, and projecting from the view. The first item we will go over is the default UV unwrap function. Using this function without marking any seams on the mesh will cause all faces to be mapped to the same location. This can also be done by using the reset function at the bottom of the menu. To effectively unwrap a mesh using this method, you must have seams available. Adding seams to a complex mesh can be tedious, but often pays off in the long run. The next UV mapping method is called smart UV projection. This is slightly more complicated and requires some simple parameters. However, for large and complex meshes, it can be inaccurate and fragment the UV representation. The good thing about this method is that it is relatively fast to do, requires no seams, and is effective for simple objects. Next is the active quads option. This requires your mesh to have faces with only 4 vertices, and will unwrap the mesh according to the length in between. It is easy and fast, and useful for straightening out curves in a UV representation. Again, it also doesn't require any seams and only requires a starting face to begin from. After this, we also have sphere projection. This is view dependent and is optimized for unwrapping spherical objects. It is fast and requires no seams, but works poorly for objects that aren't spherical. The last option we will look at is projecting from the view. Under UV mapping, there are 2 options for projecting from the view, one with bounds and one without bounds. Projecting with bounds means that the UV representation is not scaled beyond the size of the texture image. Projecting without bounds means that the UV map can be scaled as large as it is in the view. This method is also view dependent and doesn't require any seams. However, it only works best for objects that don't move and can only be seen from a fixed location, as this method will literally project an image onto the mesh from the current view. Now that we know what UV mapping is and the different unwrap methods,